All right, we're going to start talking about making maps and cartographic practices this week, and we'll finish up after the midterm exam. So there will be some material from this lecture on the exam. If it's not a topic covered by this lecture that's in chapter 4, you don't need to worry about it for the exam because we'll cover the rest of that after. But if it's in the lecture, if that topic is in the lecture, then it's fair game for the exam. And then next week we'll have a midterm review session. Does anybody have any questions on that? I haven't figured out the timing for the midterm exactly yet. I've only done midterms with in-class sessions via Blackboard, so the midterm was available during the class session, but I'm trying to figure out whether it's worth trying to make it a flexible schedule. Would that be of value to people if I gave you, say, 3 to 5 days window and you got to pick your window? You'd still have a limited amount of time to complete the exam. I think I can set it up that way in Blackboard. So the only dangers with these timed tests is if you got disconnected and tried to reconnect, I think it'll be a potential problem. But you can always, I guess, start from the beginning and let me know you had a problem and we'll figure it out. So hopefully there will be no crises. Hopefully you've all found good internet hideouts by now. All right, let's talk about the fun part of GIS, making maps. Oh, see, did I miss anything? Oh, right. You have a new in-class assignment starting this week. I'd like you to go visit all of these amazing wikis full of maps that you guys have made and, you know, make, I think I said on the lecture page or the class page to make 2 comments on another class member's. Oh, I didn't link it. Shoot. Sorry, guys. To make 2 comments on your co-students' wiki pages. So that is an assignment worth 3 points for this week, in addition to your lab. Next week will be a review week, so you'll have some time to catch up if you need to, and I would very much like to see everybody get caught up before the midterm, and you'll have all the materials at your fingers for the midterm. I tend to do open book, open note midterms and pace them accordingly. So you'll need to have a good understanding of the material, but you'll be able to access references, which is kind of how I live my professional life. So, all right. Cartography. John Wiley and Sons, I believe you can get digital copies online. This is a great reference, been around since 1995. I think it's not the first edition, but is a great reference for GIS if you intend to work as a GIS professional. So cartography is the art and science of organization and communication of geographically related information into maps or charts. So just basically what we've been talking about all along, you're taking real world objects and you are representing them on a map, and that interpretation can take a lot of different forms. So here, another way to say the same thing, we're collecting information about real world features and turning them into objects in our GIS system that have some sort of attribute associated that allows you to distinguish them from other objects. So here we've attached an attribute of power line, or some code that means power line is typically what you would see. And then we've said make all power lines this fancy red and white symbol, which is actually a really great cartographic symbol because it shows up well on a lot of things. So part of that interpretation of reality into a map is to take all of this information, typically far more information than you can represent in a 8.5 by 11 sheet of paper or a 3D mapping environment on the web, because that's not what you're trying to do. You're trying to model. You're making some sort of interpretation of that, and then figuring out the best way to present it to your viewer so that your viewer can communicate. And I think that's a really important thing to take in, especially as we talk about cartography practices, is this, the difference between how you are going to view your own map and how a off the street fresh viewer is going to view your map. You've typically spent a lot of time immersing yourself in the data. You may have done extensive data analysis. You have a lot of familiarity with the contents of your map, and you are less likely to see the things that could be puzzling to somebody else. So I think it's a really important part of any map production process to take that final step, or hopefully not final step, but iterative process of having a fresh viewer come in and take a look at your map and ask questions and give feedback so that you can figure out what you might need to change to make it easier for people to understand. And I like to see that as an iterative process. So they ask questions, I make changes with the feedback. I show it to somebody else, they ask questions, I make changes. It's a good way to, suss out some of those problems ahead of time. So for the cartographic part of using GIS, you've already gone through a lot of the data analysis process, though I would say it's pretty hard to do data analysis on a lot of spatial data without visualizing it in a map at some point. But a map is just one element of a GIS system. It's not even a required element. A lot of our projects that I've done in the past will take in data, we'll do analysis, and we will deliver that data to a client in a geodatabase format. So they have access to that within their own GIS system. I've never done that though without having a map to view the data to do quality control with. So it's a really important element. But then the cartography aspect of that is taking it one step further and producing a map that can be a deliverable to somebody. So it's something that you're willing to put in front of somebody else, whether it's a client or somebody off the street. You have to decide how much effort you should be putting into this to put your best foot forward. So map production and cartography doesn't necessarily involve data analysis, though you might need to do some very base level analysis to figure out how to best represent your data. So we'll be getting into data analysis later in the semester. So just keep that in the back of your head. That's another component to the GIS process. Can you guys hear me okay? I know my voice is a little quieter today.
Yeah, you're fine.
Okay.
Got you loud and clear.
Awesome.
Yeah.
The university was kind enough to loan me a very nice microphone, so. All right, so the elements of a map. The key elements of the data that you're bringing into your system are what we call figure and ground components. So your figure is essentially the pieces of data that make up the story that you're trying to tell. And your ground is the background that you've chosen to put behind it. And depending on what story you're trying to tell, that ground may be very simplified or it may be very complex. And all of those go together into figuring out the style and the purpose and the tone of your map, how you're going to present that to your viewer. So I did some searching around on the internet because I've never had a really satisfying list of cartographic elements, and I found that there don't appear to be any really complete, satisfying lists of cartographic elements because there's so many different things out there that kind of fit that category, and their use is different depending on what maybe what type of scientific arena you're in, or what your trade practices are, or even what part of the world you're in, or your point in history. We'll look at a couple of historic maps here in a little bit. Those typical cartographic elements change, and your selection of cartographic elements, again, go back to the purpose of your map. So Like I said, I think in lab 1, there's a whole bunch of elements built into ArcGIS that you can add to your map. And I can't tell you that every one of those is required, but I do highly recommend that you consider each of them and how they may add to or detract from your map, because there is such a thing as having too much information on a map as well. So I think, I wonder if I can have 2 things up at once. So we can go through that list with a visual. Your border in that list is the white area around your map. And I've had a couple of questions actually from you guys about the maps that I tend to make versus the maps that you're seeing in Bolstad's labs. And I think probably where that comes from is he comes from a somewhat more traditional map making background, where having a border around the edge of your map is not only necessary for printing, but ideal for visual effect. Whereas I come from a background where my maps tend to be used more in figures and report production, and that white space is something that either I don't want or I want to be able to control it within my publishing document. So for me, I find I have less issues with that final adjustment if I have no white space to deal with. So again, the border is one of those things that comes back to what's the purpose of your map. I'll try not to kick that horse too much more, but so your media edge is the typically the printing edge. So I guess actually this would be the border on the inside of this. This would be just extraneous white space, probably, that I added, yeah, to the presentation. So this is your border. Oops. This is your media edge, and then we have what's called a neat line, and that's the line that goes around the data in your map. So you'll hear that neat line term thrown around a lot, and it really just means the border of your data. So in the map view that you add to a layout, your layout could contain a border, and the edge of your map view in ArcGIS would be your neat line. And you have some control within ArcGIS if you're going to add, say, a grid and you need to annotate tick marks or some sort of gridding notation on the edge of your neat line. That can be within or without your neat line, depending on how you change your settings. So the next step into your map would be the title. Typically you want to have the title prominently displayed. There's a lot of I should say best practices that go into laying out a document that are often ignored in mapping. One of those things is you're not necessarily going to center your title at the top or the middle of your page. You're going to put it wherever it makes sense around the geographic features of your map. So it looks to me like this one is offset a little bit to the right because the upper left corner of the United States sticks up a little bit there. So by entering into the realm of map making, you get to break some of the rules of printing and publishing, which I always like to have an excuse to break the rules. So I didn't list data pane in your elements because it seems fairly obvious you can't have a map without map data, but that would be the primary data window of your map. And then the last 3 features that I think are essential to at least consider, you can always reject them if needed. For example, I don't put titles on a figure in a report. I'm going to put a caption on the report, so the title is not necessary. But a north arrow and a scale bar and a legend. North arrows are one of those things you can throw out, but only if your map is north up, because that's the international convention. And we'll talk about how that happened, I think, here in a little bit. A scale bar is only necessary if you think people might care about distance. I would say probably 90% or maybe 75, somewhere between 75 and 90%, it's a good idea to have a scale bar. But there are times where you're just making a pretty picture or you're just presenting information on a wide enough scale that there's no reason for people to be measuring. And as we've learned in the previous labs, there's some projection systems that don't lend themselves well to measuring, especially on a very large global scale. So again, you want to look at your map layout with an eye of a stranger if you can, or better yet, grab a stranger and have them look at it with you and help you ensure that the purpose of your map is clear to other people. This one, I would say, seems pretty clear to me. You have two different shades of gray, and they mean two very clear different things. And the US is pretty clearly displayed. So, not the world's most exciting map, but it doesn't need to be. This is actually a really cool historic map. This is from 1638 and is one of the earlier global maps of the world produced after the discovery of the Americas. So it's from the golden age of Dutch cartography. So this style was very formative for European mapping. And other than the mapping information that it's trying to convey, it conveys a lot of decorative elements. So the figures that are around the edge, it said, I have a note here somewhere. Nope, I don't have a note. But some of them represent the seasons. Some of them represent the planets that were known at the time and the sun and the moon. The bottom 7 represent the 7 wonders of the earth. And then the 4 on the left represent the elements, which I think is a interesting thing to add to a map. You're basically saying this is all information of world importance, which from a Eurocentric view, it probably was, but maybe not from a global view. So there are a lot of elements to this lab, or to this map, a lot of cartographic elements. The first being the title, which I can't read for you, but I can read you the interpretation. It's basically a hydrographic map of the world. I did leave that out. But anything hydrographic is good by me, so. You'll notice this has a, we'll get to the difference between graticules and grids later, but this has a grid system around the edges. You can see faintly the gridding bars that go around the edge. And then if you zoom in, you can see the numbers. And you'll notice this is the prime meridian for this map. Does that jump out to anybody? The location of that prime meridian?
It doesn't look like it lines up with Greenwich.
It does not. It doesn't even pass through England. Yeah, so we think of the prime meridian as this really important piece that's been around forever, but that's an English tradition, not a Dutch tradition. So I doubt that they still use this meridian at all, but at the time that was the prominent choice. This piece is the intersection of those, the equator and the meridian. So just a nice decorative element. You can see the north arrow there. So they've included, interestingly enough, this theme repeats in several different places. So you've got north arrows spread around the map. Here's another one, though this one doesn't show the N anywhere, obviously. It still has the same theme approach and still points north, so it's a good assumption. And then these are map insets. So there's another one over here. This is the one from the lower right, and they show what's happening at the South Pole. So this is a representation of Antarctica, which, can I go back? No, can't go back. Oh, there we go. If you'll notice the Mercator projection, the edge of Antarctica is spreading all along that bottom of your map. So they've included this little inset here to kind of help with the interpretation of that point, which I would say is a really great cartographic practice. So there's things about this map that we probably wouldn't necessarily do anymore, but a lot of good elements that were fundamental to the development of map making. Did I forget to record? No.
No,
Okay.
it was recording.
Thanks. It doesn't make that obvious to me, so I'm glad it does to you guys. Okay. So talking about north arrows, there's a link in the presentation you guys can grab off of the lectures in the Google Drive, and I'll get those links fixed on the class webpage. But this is an interesting article about the convention of showing north up. There is absolutely no reason that north needs to be up. We could have easily evolved as a south up mapping convention, but that has become the international convention. So it's pretty critical if you're going to show your map in a non-north up orientation, which I think is totally appropriate, and I do it all the time, especially for Arctic projects, to include a north arrow. That's one of those points at which that element is no longer probably optional if you want the majority of humans who know how to read maps on our current planet to be able to interpret it. So you'll notice in this one, you can really clearly see Cape Horn and somewhat clearly see Africa. This is what the Earth looks like from the Southern Hemisphere's perspective. And there was actually a campaign at one point in Australia to change that convention, but since they were a colony, it didn't go very far. So grids and graticules. Essentially, a grid is pretty straightforward. Those are used in planar mapping conventions, and a graticule just means that it's representing lines of latitude and longitude. Now, if you're working in a projection system where latitude and longitude are perpendicular, your graticule might also be a grid, if that makes sense. You may have right angle intersection of all your lat long points, and then it will look like a grid, but it will still secretly be a graticule. So that's mostly just a point of map terminology and trivia. Okay, I found a fun new Pear Deck tool. This is the whole reason for logging into the Pear Deck today. And the point of this one is to vote for which of the maps is the large scale map. So drag your flag and plant it. You can plant it on the landmass if you so choose, or in the ocean if you want to go diving, but make sure you put it on the map that is the large scale map. We have an even split. All right. So this is always going to be tricky. On when we're talking about scale, we're talking about a ratio. So we typically present it in either inches to inches, miles to miles, but we always start with the 1. So if you remember back to elementary school fractions, a half is bigger than a third. So the amount of area that you cover is on the bottom of that fraction, meaning, okay, you're supposed to go on to, or maybe it won't let me, I can't do the big unveil with the responses shown. Ta-da! The smaller the area, the larger the scale. And I will always have to repeat that in my head to make sure I get it right. But it's an important, more important than graticule versus grid. You will always have this question coming up. You will always have people referring to large and small scales. It's a good idea to check and make sure that they know what that means, because they might typically know what that means, but just like left and right, I get it wrong all the time. Probably worse at left and right though. So label placement on mapping is really important. I'm not sure that I would agree that there's necessarily strong rules, although there's definitely historic conventions. So these are some of those historic conventions, and probably traditional map makers and map viewers would have something to say if you violate them, but again, my philosophy is rules are there to be broken, but if you have good reason. So conventions for points, it's more comfortable and natural for people who are used to looking at traditional maps to see your point labels on the upper right, but only if it doesn't overlap an important feature or another label. So ArcGIS has some good placement strategies for that. It basically grids off all of the cardinal locations around a point, and you can set priorities for those. So as you go through, points will shift themselves to move out of the way of other points to the extent possible. And then you do have a final level of control within ArcGIS. You can convert those to features themselves and then drag them around with your mouse. I like to do as much as possible with the built-in tools for label rules to get things looking the way I want before I start dragging them around, because at that point it's more difficult to make global changes. So we'll look at that a little bit more next week in our lab. Lines have have varied approaches that you can take. You can have the text follow the line. You can have the text inset into the line, like the Rio Tahoe. If your line is really wavy, has a lot of variation in it, I would recommend sticking with a more straight approach than trying to have your label wiggle along with it. But it is conventional with water features to have the label follow the water feature. If you have other line features, that's less conventional. Typically, you would stick with a straight text or flat text. And then with areas, again, there's a convention to label lakes within the internal boundary of the lake. There's not necessarily a convention with other objects. But again, if you have a lake you need to label and the name won't fit well, you can always stick it outside. I would recommend, in most situations, having a line come out to point at that area so there's less confusion or less chance for confusion. You typically want to have your labels visible from the direction that your viewer is going to be viewing them, so keep them upright or angled in such a way that you can read them as if they were upright. I was not aware of this convention of having text read up on the left of the map and down on the right. That seems like it could be important on a large map where your head might be in the middle of a 4-foot wide map that you might be moving around so you can see all of it, but maybe less important on a small map. But it's an interesting factoid. All right, so now we're going to get into types of maps. And our previous instructor on this course had a header slide to this section that tried to lay out a kind of a system of classifying types, but then immediately got into breaking that system. And I think it was just a really good representation of the fact that there are hundreds of different map types available. I'm going to give you a list of kind of the most popular 10, but there are lots of other map types out there, and many of them overlap in their features, so that it's really hard to categorize them. So I threw that slide out. I didn't feel like it was an important piece of knowledge, but he was classifying by points and lines and areas, things which I feel like are used really interchangeably on a lot of maps. So the first one, most common, is a feature map where you're directly identifying features in their location, geographically speaking. So this map, gosh, I should have figured out which state that was. Is that Maine? somewhere over there in the Northeast where I've not been in many years.
It's a few different states in
Wow.
the Northeast.
Thanks. I wandered around Vermont for a while, but all I saw were trees. So, okay. So on a feature map, your location of your symbol correlates with your geographical location. So that's an important thing to keep in mind. You're going to generalize to some extent, and there's a lot of different ways you can manage that generalization. You can filter out cities and towns based on how complete your list is. You can filter them out based on their population size, whatever feature you want to highlight, or whatever attribute, sorry, you want to highlight, can choose whether or not you display a feature. A symbol map is similar to a feature in that you're typically identifying your feature in place, so at its point of occurrence, but you're representing it instead of using this abstract symbology, you're representing it with a meaningful symbol. So I swapped out the one that the professor had used that had skulls and crosses, first of all because it didn't have a citation that went with it, and second because it just felt a little violent for this time. So we're going with slides and ducks. Each of your slides in this playground is represented by a interpretive symbol, which in this case is a slide. It doesn't necessarily have to be that closely correlated. In the skulls and crosses example, I forget what he was representing, but they were clearly heinous, whatever they were. The ducks are not a great example of mapping because you wouldn't map a duck because they move, but maybe it's a duck sculpture. Anyway, this is an introduction to mapping for elementary school students and is available from NGS if you have any precocious children who want to learn about mapping. The graduated symbol map is, I think, a really powerful tool to really quickly represent information. So this is yesterday's earthquake map of Alaska, one of my favorite websites. You'll, if you start peeking at it, you'll kind of get obsessed with how many daily earthquakes we have. It's crazy. And this represents them based on their magnitude. So you can pretty quickly distinguish areas where we have a lot of large magnitude earthquakes versus areas where we have a lot smaller earthquakes. And then they've also gone further and symbolized that using two different color symbols, which can quickly represent what's happening today. So this is a fairly typical earthquake map of Alaska. If you go back in some of the historic data and you look at, say, the last big earthquake that we had, that's been 2 winters now, you'll see a lot of really intense activity around a certain point within the last 24 hours, and it can help you quickly interpret the fact that something's going on. And essentially, that's part of what they see in the Tsunami Warning Center when they're sitting there on their watches. They keep 24-hour watch for tsunamis. Part of what they see is that change in the visual representation of the data. They're also doing huge amounts of data analysis and coding on the back end. If you ever get a chance to tour that place, it's really impressive. I would love to just sit there and watch how they analyze all that information coming in from monitoring systems around the world. And really doing on-the-fly remodeling of what the likely outcome of a specific event might be. So cool place and cool maps, and they've done a really nice representation. You'll notice that the ground on this map, which is the background, is very muted. It's not really meant to represent a whole lot other than to help you place these earthquake events within Alaska. Right, so this is an example of a network map, and I thought an interesting example because at the same time, it's also a graduated symbol map, right? We have here a map of the roads across the lower 48 and a little bit in Alaska, showing the amount of daily truck volume based on information from DOT. So this is actually a forecasted system for 2035. So helping to identify areas where they may need to expand infrastructure to meet predicted needs. So the width of your line doesn't in any way represent the existing infrastructure. It represents the predicted demand. So it would probably be a helpful way to compare that to existing infrastructure is to map the capacity, the daily capacity flow, and show that visually in the same way. And that might help things jump out to your eye as needing attention. More likely that information or that analysis happens with the data, but it'd be a good way to make a sales pitch to somebody who's spending money on roads. So if you want to get more money from federal highways, make a map that shows you need more money. Federal highways always seems to have lots of money. Right. One of the other classic map styles is the chloropleth map. And this just uses color shading, or in this case, gray shading, to demonstrate your attribute that you're trying to express. These are often done in a single color family, so you'd have different shades of green, different shades of blue. That's especially common if you're showing the attributes or a variety of attributes from the same area. So if you had one attribute colored green, another map that just showed purple, that's a common way to do it. You wouldn't tend to see this done with a lot of different colors because that would be less easily interpreted by your audience, unless you had a really good reason to do that. So again, there's always reasons to break the rules. The concept of normalization is really important for this one because this is so dependent on area. You're visually representing data over a large area, and I took out a map, maybe I regret it a little bit now that our predecessor had included showing different representations of the results of a vote. If you represent the counties that voted Democrat or Republican, you're going to see a very different bit of information than if you use, say, like a graduated symbol to represent the number of people, because there's a huge difference in the distribution of votes by population versus votes over area. So that's just one example of a way that you can skew your viewer's interpretation of the data. You're not lying about the data. You're showing what happened on a map. But you're showing it in such a way that they might draw a different conclusion than they would have if they'd seen a different set of data. So normalization is something that we use to help combat that. If you have a large, well, whatever attribute you're trying to represent, you would divide by the area and use that resulting number to fit into your chloropleth range. And that helps to reduce some of the impacts of large areas. So like in these larger counties in the upper, if this were a normalized number, they would probably, well, this is a normalized number because it's per square mile. So that just helps to represent that extra space that's out there. So a dot density map is something that could be easily misinterpreted as a feature map, very similar to the feature map that we looked at the very beginning of our map styles. But these dots don't actually represent, or don't actually have to represent, anything meaningful on the ground where they're placed. Based on the kind of random distribution, or not random, but the suspiciously not random distribution of these points, I think that they've probably been tied in some way to centers of population that are a little bit tighter than a county. I think these probably correlate somewhat with towns, but they don't have to. And that's the point of a dot density map, is each one of these little counties should get a similar number of, or a number of dots based on the population of that county. So I think this is probably divided up even smaller and turned into a dot density map, which is then shown in a county perspective. But really what a dot density map is help you identify aggregates of lots of whatever attribute you're looking for in a way that isn't necessarily tied to the scale of your map. So say you were looking at populations in the United States as a whole, and you had some reason that you wanted to identify that with a point. you would use a dot density map to show lots of crowded points together. So there, it kind of bridges that border between a feature map and say a graduated data map. Another popular style, and this isn't quite a classic representation of a cartogram, but I thought it was a really effective map, so I included it, is to take your area, so it's typically used for areas, so whatever shape your area is, and then represent its size according to the attribute. So it helps to communicate your attribute. So especially if you look at the difference between Alaska and Texas. Texas is clearly a primarily privately owned state, and Alaska is a primarily not privately owned state. And that obviously has huge implications about our land usage and our land access rights. But there's a lot of other ways you can use the cartogram. You don't necessarily have to have the United States behind there, so you can have some rearrangement of your features and control over that. There were some neat examples of that that I wasn't able to fit in. But I think this is a really effective use of this tool. So just one interesting map style. I'm not sure that actually ArcGIS has a lot of capability for this built in. I'm guessing, I think this is the SAS users blog, is a statistical package. So it might take some extra computing power to show something like this that I don't think is currently available through ArcGIS, so I could just not be aware of it yet. We do have access to a lot of expensive licenses that I don't typically, so I'll have to check that out now that I've said it. Okay, an isoline map is maybe a strange name, but a familiar map style. It's simply representing lines of equivalent attribute. So in the example of elevation, a contour line on a topographic map is a line of equivalent elevation. So your elevation is your attribute, and you're simply representing nearby similar points by connecting them with a line. So the brown map of Pakistan by the CIA on the top of this is a really good example of a reference map. It's just a really simplistic map that helps to put whatever your topic is in context without distracting with a lot of detail. The one in the background was meant to be an example of a reference map, but I think it's a little too interesting to be a reference map. You have a lot of visual information going on there with the topography. You clearly have Afghanistan pushed to the front to separate it from the states behind it. But it might be a good example of a quick reference map if you were trying to quickly communicate the topography of Afghanistan, and the fact that you're focusing on Afghanistan as a country, it's probably pretty effective for doing that. I would say it has a lot of cartographic problems. It's almost impossible to read the legend on my screen. I tend to keep everything dim. There's a lot of visual things that could be balanced better. The text within Afghanistan isn't very visible, but it sure is a beautiful topography map. It's also a good identification of how much control of the coloration of your topography can change people's interpretation of your map. It's a really good idea if you're showing a mountainous area to find out at what elevation the snow line is really meaningful. So I wouldn't draw an elevation of the snow line in Anchorage in the winter. I would pick some season at which either, you know, in the middle of the summer where you have just your constant snowpack, or somewhere in between, but I wouldn't extend white a whole lot beyond that, or people are going to think that that's always a snowy area, because that's the immediate thing that your brain jumps to when you see that on a topographic map. But it doesn't mean that, it only means elevation. So something to keep in mind when you're controlling a gradient representation of a attribute like this. The colors in your gradient are instantly open to interpretation. Same thing at the other end of the spectrum with the green. It's going to suggest to your audience that that area is vegetated. So you want to be careful using that in places where it doesn't necessarily correlate well. Okay, so this last one is kind of getting beyond the realm of laying out a map in ArcGIS, but it is another mapping style and requires three-dimensional view. It's not actually a 3D map because we're showing it on a two-dimensional surface. So that's where the convention of 2.5 dimensional comes from. When you get into things like the mapping box, if you haven't seen it yet, the Geomatics program has a neat system for showing 3D maps. That would be truly 3D. This is the representation of 3D. And the way that we attempt to represent 3D on a 2D surface is by showing perspective. So in the image in the lower right, you have a grid laid over a surface, a mountainous surface, and your grid has been distorted to give the impression that the object is 3D. So that grid is no longer meeting at right angles, it's no longer planar, because it's been, each cell has been deliberately distorted to represent the altitude in that shell, and to do it in such a way that the perspective being skewed helps your eye and your brain interpret that as three-dimensional. So there's a lot of kind of complex distortion happening to this image to make your brain interpret it properly. Interestingly enough, the way that different people perceive color rendered shaded objects is different. So I should have included in here a color rendered bathymetry. I happen to be handicapped in that I interpret color rendered shaded objects opposite most viewers. So when I see what looks to you like a divot on a map, it looks like a mountain to me. I'm not sure what the actual mechanism, whether that's a learned problem that I have, but working as a hydrographer, it was something that I had to keep in mind when I looked at somebody else's monitor and said, oh, look at all those pretty underwater mountains, and they weren't mountains. So something to keep in mind when you're representing a color rendered bathymetric or even a mountainous surface, make sure you include a scale bar so that people can correlate the colors to the scale bar and make sure they're interpreting correctly. All right, so I said at the beginning they're hard to categorize. There's a couple of different ways that people attempt to categorize them, but I would say a lot of these map types probably overlap into multiple categories. You very seldom just present features, you typically talk about their attributes as well. You very seldom only see areas on a map. You generally at least have some points of interest marked out on that map to help put it into context. So map type is a sliding scale.